Leonardo da Vinci's armored vehicle, the Renaissance war machine. Leonardo da Vinci was not only a master of painting, anatomy, and architecture but also a visionary military engineer. Among his numerous conceptual inventions, one of the most intriguing was his armored vehicle, often regarded as the earliest prototype of a modern tank. This war machine, designed during the late 15th century, was a unique combination of defensive shielding and offensive firepower, a structure meant to revolutionize the battlefield of the Renaissance era. Da Vinci's design was intended to be an unstoppable, mobile fortress, capable of moving in any direction and firing from all angles. This was achieved through a circular arrangement of light cannons, which could unleash firepower in a 360-degree radius. Unlike the metal-plated armored vehicles that would emerge in later centuries, Da Vinci's machine primarily used wooden panels, reinforced with metal plates, to provide both durability and maneuverability. The most striking feature was its turtle-like shape, which not only made it aerodynamically resistant to direct projectile impact but also reinforced its fortress-like appearance. Despite its futuristic and formidable design, the armored vehicle was never built in Da Vinci's time, largely due to mechanical limitations and strategic impracticality. Innovative structural design and defense mechanisms. One of the most remarkable aspects of Da Vinci's armored vehicle was its sloped exterior, designed to deflect enemy projectiles rather than absorb them. The roof was built at a 45-degree angle, which would, in theory, cause incoming arrows, stones, or primitive cannon fire to glance off rather than penetrate the structure. This design principle was centuries ahead of its time and would later be incorporated into modern tank armor, where sloped plating enhances defensive efficiency. At the top of the vehicle, a small lookout turret was included. This crucial element allowed an onboard commander to survey the battlefield, direct movement, and coordinate firepower. Given that visibility was a major limitation of enclosed war machines, this turret was an essential feature to provide battlefield awareness. The circular formation of cannons inside the vehicle was another groundbreaking aspect. Rather than focusing fire in a single direction, the ability to fire from multiple angles simultaneously gave the armored vehicle a strategic advantage, making it difficult for enemies to attack from a blind spot. This concept foreshadowed modern turreted tanks, where rotating weapons allow for maximum adaptability in combat scenarios. To enhance its mobility, the vehicle was designed to be powered by 8 men stationed inside, who would manually rotate a series of hand cranks connected to the wheels. This system, while innovative for the time, was ultimately flawed due to its complexity. Many historians believe that Da Vinci may have intentionally designed a flaw in the gearing mechanism, rendering the machine immobile or ineffective. Some speculate that this was a deliberate choice, either as a way to prevent misuse of his invention or as a safeguard against his designs being stolen by rival factions. Mobility, mechanical challenges, and strategic limitations. Despite its brilliance in concept, Da Vinci's armored vehicle faced major practical challenges, particularly in its mobility and maneuverability. The design relied on a hand-cranked propulsion system, meaning that the speed and movement of the vehicle were entirely dependent on the physical strength and endurance of the soldiers inside. This significantly limited its effectiveness in real combat, where speed and agility were crucial. Another major flaw in the design was that the wheel arrangement and gearing system made it nearly impossible to steer efficiently. Some historians argue that if the machine had been built as per Da Vinci's original sketch, it would have likely moved in circles rather than being able to traverse a battlefield. This issue might have stemmed from an error in the gear ratio, but given Da Vinci's genius, it is possible that he deliberately included this flaw to ensure that his war machine could not be easily replicated or weaponized. Beyond the mechanical flaws, there was also the issue of weight and practicality. With its thick wooden panels reinforced with metal plating, the vehicle would have been incredibly heavy. making it even more difficult to move using only human-powered cranks. Additionally, the open flame required to fire the cannons would pose a serious risk inside the confined interior, as smoke and heat could quickly overwhelm the operators. Even if these mechanical issues were resolved, the strategic value of such a machine was questionable. While it could provide a defensive stronghold on the battlefield, its slow movement, large size, and reliance on manual labor would make it an easy target for more agile and coordinated enemy forces. In essence, Da Vinci's armored vehicle was a brilliant concept that was ahead of its time, but it lacked the practical technology needed to function effectively in battle. Da Vinci's legacy and the influence on modern tanks. Although Da Vinci's armored vehicle was never constructed during his lifetime, his work laid the conceptual foundation for modern armored warfare. The idea of an enclosed, mobile, gun-equipped vehicle would not re-emerge until centuries later, particularly during World War I, when nations developed the first true tanks. Many of the principles Da Vinci explored, sloped armor, multiple gun placements, and a turreted lookout, would later become fundamental features of 20th and 21st century tank designs. Modern reconstructions of Da Vinci's armored vehicle, using computer modeling and historical blueprints, have shown that if the mechanical issues were corrected, the design could have been functional. Some working prototypes have been built in recent years, using modified gearing systems, proving that Da Vinci's vision was not entirely impossible, only limited by the engineering capabilities of his time. Despite its flaws, the armored vehicle remains one of Da Vinci's most iconic military designs, showcasing his innovative mindset and futuristic thinking. His ability to blend artistic creativity with mechanical ingenuity is what set him apart as one of the greatest minds of the Renaissance. His war machine, while never deployed in battle, stands as a testament to his boundless imagination and engineering brilliance. Da Vinci's self-propelled cart, the Renaissance's first step toward automobiles. Leonardo da Vinci was a man of boundless imagination, constantly pushing the limits of what was possible in his time. While his name is often associated with paintings such as the Mona Lisa and the Last Supper, his genius extended far beyond the canvas. Among his many futuristic inventions, one of the most groundbreaking was his design for a self-propelled cart, an idea that anticipated the development of automobiles centuries before the first steam-powered vehicles were built. Between 1478 and 1485, Da Vinci meticulously documented multiple sketches and mechanical diagrams of his self-propelled cart in his notebooks. Unlike the traditional horse-drawn carriages of his era, his design proposed a vehicle that could move independently, without any external force, something entirely unheard of at the time. If fully realized, it could have revolutionized transportation as early as the Renaissance period. However, due to technological limitations and a lack of proper materials, his invention remained purely conceptual for centuries. In the modern era, engineers and historians have revisited Da Vinci's blueprints, attempting to bring his visionary ideas to life. In a remarkable achievement, a team of engineers from the Museum of History and Science in Florence successfully built a functioning model of Da Vinci's cart. After 8 months of meticulous study and reconstruction, they were able to demonstrate that Leonardo's design was mechanically sound, proving that he had, in fact, conceived the world's first self-moving vehicle. Engineering marvel, how Da Vinci's cart worked. At first glance, Da Vinci's cart resembles a primitive wooden vehicle. But its inner workings reveal a highly advanced mechanical system. Unlike modern automobiles that rely on combustion engines or electric power, Da Vinci's cart was propelled using coiled springs, a technology more commonly associated with clockwork mechanisms. The cart's movement was based on stored mechanical energy. Here's how it worked. The springs and release mechanism. Inside the cart, large, wound-up springs stored energy. When the cart was ready to move, these springs were released, causing a sudden burst of mechanical energy that turned the wheels. This principle is similar to how wind-up toys function today. Gear-driven motion. To ensure proper movement, Da Vinci integrated a gear-driven transmission system. This mechanism allowed the stored energy from the springs to be gradually distributed, preventing an uncontrollable burst of motion. Directional steering system. One of the most fascinating aspects of Da Vinci's cart was that it could steer itself. The vehicle was equipped with a set of pre-programmed cams and gears that controlled its direction, making it one of the first examples of an autonomous, self-steering mechanism. Limited travel distance. Although Da Vinci's design was ingenious, there was one major limitation: the cart could only move a few meters before stopping. Since the system relied solely on wound-up spring power, its energy would deplete quickly, requiring frequent rewinding. While his cart was never built in his lifetime, modern reconstructions have demonstrated that it was indeed a functioning, self-moving vehicle. This suggests that if given the right materials and technological advancements, Da Vinci could have pioneered self-propelled transportation more than 400 years before the first automobile was invented. Limitations and why it was never built in Da Vinci's time. Despite its brilliance, Da Vinci's self-propelled cart never replaced traditional horse-drawn carriages. Primarily because it had several practical limitations. Short travel distance. The reliance on spring power meant the cart could only move a few meters at a time before needing to be manually reset. Unlike horses, which could travel for miles, Da Vinci's vehicle required frequent winding, making it impractical for long journeys. Lack of suitable materials. The Renaissance era lacked the precise metalworking techniques needed to build intricate gears and springs capable of sustaining prolonged movement. Had stronger materials been available, the cart might have been able to travel greater distances. No demand for self-propelled vehicles. In the 15th century, there was no real need for an alternative to horse-drawn transportation. Roads were not well developed, and the infrastructure to support self-propelled vehicles simply did not exist. No practical energy source. Unlike steam engines or combustion engines, Da Vinci's design relied solely on mechanical energy, which meant that once the springs were fully unwound, the vehicle would come to a halt. This made it impractical for any sustained use beyond short distances. These limitations ensured that the self-propelled cart remained an unrealized concept, existing only in Da Vinci's notebooks until modern engineers revived his work centuries later. Da Vinci's legacy and influence on modern automobiles. Even though Da Vinci's cart was never put into practical use, his ideas foreshadowed the development of modern vehicles. The principles behind his gear-driven motion system and self-steering mechanism bear striking similarities to the automatic navigation systems used in modern robotics and autonomous cars. His concept of a spring-powered vehicle also directly influenced later clockwork-driven machines, which became common in the 17th and 18th centuries. The idea of storing mechanical energy and releasing it to produce motion would later inspire inventors like Isaac Newton and James Watt, whose steam engines eventually paved the way for the first real automobiles. Today, working replicas of Da Vinci's cart have been built, proving that his designs were not only visionary but also mechanically sound. These models serve as a testament to his genius, showing that he was thinking centuries ahead of his time. Da Vinci may not have lived to see his cart in motion, but his work remains a cornerstone of mechanical engineering history, bridging the gap between the Renaissance and the modern age of transportation. Leonardo da Vinci's diving suit, a revolutionary military invention. In the late 15th century, the Republic of Venice found itself in a precarious position, facing naval threats from the Ottoman Empire. As a maritime power, Venice relied heavily on its fleet, but against the formidable Ottoman navy, traditional naval warfare tactics were not enough. To counter this, Leonardo da Vinci devised one of the most visionary yet daring military inventions of his time, a fully functional diving suit, designed to allow underwater sabotage. Long before the development of modern scuba diving gear, Da Vinci conceptualized a suit that could enable divers to remain submerged for extended periods, sneaking beneath enemy ships to cut holes in their hulls. This concept foreshadowed modern naval warfare techniques, such as underwater demolition and stealth operations. However, the Venetian navy managed to repel the Ottomans before Da Vinci's invention was deployed, leaving it an unrealized yet brilliant design. Design and functionality. The early scuba suit. At a time when underwater exploration was virtually unheard of, Da Vinci's diving suit represented a leap forward in engineering and military strategy. His design combined waterproof materials, an innovative breathing system, and even waste management features, showcasing his extraordinary foresight. 1. Waterproof leather construction. The core of the diving suit was made from waterproof leather, a material that could withstand prolonged exposure to water while remaining flexible enough for movement. The suit was designed to be form-fitting but not restrictive, ensuring that the diver could maneuver underwater with ease. 2. Air supply system, the first breathing apparatus. One of the most advanced aspects of Da Vinci's diving suit was its breathing system. Unlike modern self-contained underwater breathing apparatus, scuba, which relies on oxygen tanks, Da Vinci's system used a long breathing tube extending from the suit to the water's surface. The tube was connected to a floating cork buoy, which kept it above water, ensuring a constant air supply. The buoy was camouflaged to avoid detection by enemy ships. The tube itself was reinforced with metal rings to prevent it from collapsing under water pressure. This system, while simple by today's standards, was revolutionary for the 15th century. The idea of supplying air from the surface was centuries ahead of its time, predating early diving bells and air pumps. 3. Buoyancy control. The inflatable air bladder. To allow divers to control their depth, Da Vinci incorporated an inflatable air bladder within the suit. This bladder could be adjusted via a valve system, enabling the diver to sink or rise by manipulating the amount of trapped air. This mechanism functioned similarly to modern buoyancy control devices, BCDs, used in today's diving gear. It gave the diver a level of neutral buoyancy, allowing for easier underwater movement without constant effort. 4. Waste management, a practical consideration. Unlike most Renaissance-era inventions, which rarely considered human limitations, Da Vinci was remarkably practical in his designs. Understanding that underwater missions could last for extended periods, he even included a pouch for waste disposal, ensuring that divers could complete their tasks without resurfacing. This feature highlights Da Vinci's attention to human physiology and endurance, a key aspect that distinguishes his work from that of his contemporaries. Strategic military applications. Underwater sabotage. Da Vinci's diving suit was not designed for scientific exploration, it was a tool of warfare. Its primary purpose was to give Venetian forces a stealth advantage against the Ottoman navy by enabling covert underwater sabotage operations. 1. Cutting holes in enemy ships. The primary tactic envisioned for the suit was disabling enemy vessels by cutting holes in their wooden hulls below the waterline. This would cause the ship to take on water and sink, rendering it useless without open combat. 2. Laying underwater mines. Another possible use of the diving suit was for placing explosive devices beneath enemy ships. While Da Vinci did not design underwater mines himself, his contemporaries were already exploring the use of gunpowder-based naval mines. His diving suit could have enabled precise placement of such devices. 3. Underwater reconnaissance. Beyond sabotage. The suit also had potential for underwater reconnaissance, allowing Venetian forces to spy on enemy movements from beneath the surface. This concept of stealth diving missions would not be fully realized until the development of combat diving units in the 20th century. Why was it never used? Despite its ingenious design, Da Vinci's diving suit was never put into action. There were several reasons for this. The Ottoman threat was repelled. Before Venice had the chance to implement Da Vinci's invention, its navy successfully defended against Ottoman incursions. Without an immediate need for underwater combat, the diving suit was set aside. Material limitations. While Da Vinci's concepts were brilliant, the technology of the time was not advanced enough to create airtight, flexible, and durable materials capable of withstanding extended underwater exposure. Risk of detection and failure. Although the breathing tube was cleverly designed, it relied on surface air intake, which could be easily disrupted if enemy ships noticed and cut the floating buoy. Without modern air tanks, divers would have been at significant risk if their oxygen supply was compromised. Diving was an unproven tactic. The very concept of underwater sabotage was radically new. Venetian commanders may have been hesitant to deploy an untested method of warfare, preferring to rely on traditional naval strategies. The legacy of Da Vinci's diving suit. Although his diving suit was never used in battle, Da Vinci's work directly influenced later diving technology. His design served as a precursor to the diving bells of the 16th and 17th centuries and laid the groundwork for early deep-sea exploration suits. The principles he established, surface-applied air, buoyancy control, and waterproof suit design, became fundamental elements of modern diving technology. Today's military divers, special operations units, and even astronauts still rely on concepts pioneered by Da Vinci. Modern recreations of his suit have demonstrated that it could have worked with minor adjustments, further cementing Leonardo da Vinci's reputation as a true visionary of engineering and innovation.